HashSets explained, step-by-step introduction. A HashSet is a data structure that stores unique values only. Software engineers use HashSet for duplicate detection, fast existence check, unique values, visited tracking, graph traversal, string problems, array problems, removing duplicates, intersection problems, coding interviews, backend validation, checking already processed IDs. A common learning topic is: how can beginners understand HashSet step by step using Java? This guide explains. Cut. HashSet basics. Unique values. Add, remove, contains. Duplicate detection. HashSet versus HashMap. Visited tracking. Set operations. Arrays with HashSet. Strings with HashSet. Java examples. Debugging tips. Common mistakes. Interview questions. 30-day learning plan. Simple definition. A HashSet stores unique values. Example. Input values 1, 2, 3, 1. HashSet stores dot 1, 2, 3. The second one is ignored because HashSet does not allow duplicates. Java. Set integer scene equals new HashSet. Scene.add 1. Scene.add 2. Scene.add 3. Scene.add. System.out println. Scene. Output concept. 1, 2, 3. Important. HashSet does not guarantee order. Why HashSet matters. HashSet gives fast lookup. Without HashSet, check if value exists by looping through list time, on. With HashSet, set contains value, average time, O1. Example. Problem. Does array contain duplicate? Slow approach. Compare every pair means on squared. Better approach. Use HashSet means on HashSet. Big picture HashSet. 1, 2, 3, and 4. It only stores values. It does not store. Key means value. That is HashMap. HashSet stores value only. HashSet syntax in Java. Import. Import java.util HashSet. Import java.util.set. Create. Set integer. Set equals new HashSet. Add value. Set.add 10. Check value. Set contains 10. Remove value. Set.remove 10. Size. Set.size. Check empty. Set is empty. Clear all. Set.clear. Step 1. Add values set string skills equals new HashSet.clear. Skills.add Java. Skills.add Spring Boot. Skills.add Docker. Set. Java, Spring Boot, Docker. If you add duplicate, skills.add Java. Set still contains Java, Spring Boot, Docker. Step 2. Check value exists if skills.contains Java. System.out.println. Java exists. Output. Java exists. Use contains when. Checking duplicates. Checking visited nodes. Checking allowed values. Validating input. Avoiding repeated processing. Step 3. Remove value skills Docker remove. Before. Java, Spring Boot, Docker. After. Java, Spring Boot. Step 4. HashSet size, int size, equals skills. Example. Java, Spring Boot. Size. 2. Step 5. Iterate HashSet for string skill, skills. Systemout.println skill. Important. HashSet order is not guaranteed. So output can be Java, Spring Boot, Docker, or another order. If order matters, use set string set equals new linked HashSet. If sorted order matters, use set of string set equals new TreeSet. Step 6. Contains duplicate. Problem. Return true if array contains duplicate. Input. 1, 2, 3, 1. Output. True. Why? 1 appears twice. Java. Public boolean contains duplicate. Int nums. Set integer scene equals new hash set for int num nums. If scene dot contains num, return true. Scene dot add, return false. Dot pattern. Hash set duplicate detection contains duplicate dry run. Input. Nums equals 1, 2, 3, 1. Scene equals read 1. Scene contains 1. No add 1 scene equals 1. Read 2. Scene contains 2. No add 2 scene equals 1, 2. Read 3. Scene contains 3. No add 3 scene equals 1, 2, 3. Read 1. Scene contains 1. Yes, return true. Step 7. Remove duplicates from array. Problem. Get unique values from array. Input. 1, 2, 2, 3, 3, 3. Output concept. 1, 2, 3. Java. Public set integer. Remove duplicates. Int nums. Set integer. Unique equals new HashSet.in. For int num, in nums. Unique.add num. Return unique. Important. HashSet removes duplicates automatically. Step 8. Preserve insertion order. HashSet does not guarantee order. If you want unique values while keeping original order, use LinkedHashSet. Public set integer. Remove duplicates, keep order. Int n nums. Set integer unique equals new LinkedHashSet. For int num nums. Unique.add num. Return unique. Input. 3, 1, 2, 3, 1. Output. 3, 1, 2. Step 9. Sorted unique values. Use TreeSet if you want sorted unique values. Public set integer unique sorted. Int prn. Set integer unique equals new TreeSet. For int num to nums. Unique.add num. Return unique. Input. 3, 1, 2, 3, 1. Output. 1, 2, 3. HashSet versus LinkedHashSet versus TreeSet. Type duplicates order. HashSet no guaranteed order. LinkedHashSet no insertion order. TreeSet no sorted order. Use. HashSet means fastest general unique lookup. LinkedHashSet means unique plus insertion order. TreeSet means unique plus sorted order. Step 10. Intersection of two arrays. Problem. Return common unique elements between two arrays. Input. Nums1 equals 1, 2, 2, 3. Nums2 equals 2, 2, 4. Output. Output. 2. Java. Public int intersection int nums1 int nums2. Set integer set1 equals new HashSet. Set integer result set equals new HashSet. For int num nums1. Set1 add num. For int num nums2. If set1 contains num, result set add num. Int I result equals new int result set dot size. Int index equals 0. For int num result set. Result index plus plus equals num. Return result. Pattern. HashSet membership check. Step 11. Union of two arrays. Union means all unique values from both arrays. Input. Nums1 equals 1, 2, 3. Nums2 equals 3, 4, 5. Output. 1, 2, 3, 4, 5. Java. Public set integer. Union int nums1 int nums2. Set integer result equals new HashSet. For int num nums1. Result dot add num. For int num times nums2. Result dot add num. Return result. Step 12. difference of two arrays. Difference means values in first set, but not in second set. Input. nums1 equals 1, 2, 3, 4. nums2 equals 2, 4. Output. 1, 3. Java. Public set integer, difference int integers nums1, int integers nums2. Set integer. Second equals new hash set. For int num, nums2. Second, add num. Set integer, result, equals new hash set dot. For int num, nums1. If not second contains num, result add num. Return result. Step 13. Unique characters in string. Problem. Check if a string has all unique characters. Input. A, B, C, D, E. Output. True. Input. Hello. Output. False. Java. Public boolean has all unique chars. String S. Set character scene equals new hash set dot. For char ch s dot to char array. If scene contains ch, return false. Scene.add ch. Return true. End. Pattern. HashSet duplicate character detection, step 14. Longest substring without repeating characters. Problem. Find the length of the longest substring without duplicate characters. Input. A, B, C, A, B, C, B. Output. 3. Y. A, B, C has length 3. Java. Public int length of longest substring, set character window, equals new hash set. Int left equals 0. Int max length equals 0. For int right equals 0, right.s.length, right plus plus. Char current equals s.char at, right. While window.contains, current. Window.remove, s.char at left. Window.add, current. Max length equals math.max max length, right minus left, plus 1. Return max length. Pattern. Sliding window plus HashSet sliding window dry run. Input. S equals ABC ABCB. Start. Window equals left equals 0. Max length equals 0. Read A. Window equals A. Max length equals 1. Read B. Window equals AB. Max length equals 2. Read C. Window equals A, B, C. Max length equals 3. Read next A. A already exists. Remove from left until A is removed, then add new A. Final answer. 3-step 15. Graph visited tracking. HashSet is commonly used to track visited nodes. Example. Set integer visited equals new HashSet. DFS. Public void DFS. Map integer. List integer graph. Int node. Set integer visited. If visited dot contains node, return visited, add node. For int neighbor, graph dot get or default node. List of f DFS graph neighbor visited. Y needed. To avoid visiting the same node again. To avoid infinite cycles. Step 16. BFS with HashSet. Public void BFS. Map integer, list integer, graph. Int start. Set integer, visited, equals new HashSet. Q integer, Q, equals new array DQ. Q.offer start. Visited.add start. While, if, Q is empty. Int node equals Q.poll. For, int neighbor. Graph.get or default, node, list of. If, visited.contains neighbor. Visited add neighbor. Q offer neighbor. In. Pattern. Q for BFS. HashSet for visited. Step 17. Already processed IDs. Real-world backend example. Avoid processing duplicate user IDs. Java. Public void process users. List of user IDs. Set long processed equals new HashSet empty. 4. Long user-id, user-ids. If processed contains user ID, continue. Process user, user ID. Process.add user ID. Use HashSet. 4. Batch jobs. Duplicate event prevention. Import files. Message processing. Avoiding repeated API calls. Step 18. Validate allowed values. Example. Allowed statuses. Created, paid, cancelled. Java. Private static final set of string. Allowed statuses equals set of created, paid, cancelled. Public boolean is valid status, string status, return allowed statuses.contain status. Use HashSet for allowed status checking, role checking, validation rules, feature flags, permitted categories. Step 19. HashSet complexity, average case. Operation complexity add O1, contains O1, remove O1, size O1. Worst case, O(n). But in most interview explanations, HashSet operations are average O1, space complexity, O of n, because it may store up to n unique values. Step 20. HashSet versus HashMap. Feature. HashSet HashMap stores unique values, key value pairs. Example, 1, 2, 3. 1 means 3. Use existence check, lookup with value. Duplicate handling ignores duplicates, updates value for same key. Common problem, contains duplicate, to sum. Use HashSet when I only need to know if value exists. Use HashMap when I need to store extra information for a key. Examples. HashSet, scene numbers, visited nodes, unique IDs. HashMap, number means index. Number means frequency, user ID means user. Debugging HashSet. When debugging HashSet problems, print current value set before check, set after add decision. Example. For int num in nums, system.out.println, current equals num, system.out.println, set before equals scene. If scene dot contains num, system.out.println, duplicate found equal plus num, return true. Scene.add num, system.out.println, set after equals plus scene. Ask. 1. What values are stored in the set? 2. Am I checking before adding? 3. Do I need order? 4. Do I need count? 5. Do I need HashSet or HashMap? 6. What should happen for duplicates? 7. Is output order important? 8. Can input contain negative numbers? 9. Can input be empty? Common beginner mistakes. 1. Thinking HashSet keeps order. Bad assumption. HashSet keeps insertion order. Reality. HashSet does not guarantee order. Use LinkedHashSet if insertion order matters. Use TreeSet if sorted order matters. 2. Using HashSet when count is needed. Bad for frequency. Set integer set equals new HashSet. Problem. HashSet cannot count how many times each number appears. Correct. Map integer frequency map equals new HashMap f. Use HashMap for number means count 3, checking after adding. Bad. Scene.add num. Bracket. If scene contains num, return true. Problem. This always becomes true after adding. Correct. If scene dot contains num, return true. Scene dot add num. 4. Forgetting to add value. Bad. 4. Int num nums. If scene dot contains num, return true. Problem. Scene always stays empty. Scene dot add num. 5. Returning false too early. Bad. 4. Int num nums. If not scene contains num, return false. Returns false after first new number. Correct. 4. Int num in nums. If scene contains num, return true. Scene.add num. Return false. 6. Modifying set while iterating. Bad. 4. Integer value set. Set remove value. This can cause runtime problems. Better. Iterator, integer, iterator equals set.iterator. While iterator has next. Integer value equals iterator next. If value equals 0, iterator.remove. 7. Forgetting object equality rules. For custom objects, HashSet depends on equals hashcode. If you store custom objects in HashSet and duplicate detection does not work, check if equals and hashcode are implemented correctly. Best practices. Set E as variable type. Set use HashSet as implementation. Set use contains for fast existence check. Set check before adding for duplicate detection. Set use LinkedHashSet when insertion order matters. Set use TreeSet when sorted order matters. Set use HashMap when count index value is needed. Set use HashSet for visited nodes. Check use HashSet for unique IDs. Check use HashSet for allowed values. Check remember average O1 lookup. Check test empty input. Check test duplicates. Check test negative numbers. Check test output order if required. HashSet interview questions. 1. What is a HashSet? A HashSet is a data structure that stores unique values and provides fast average lookup, insert, and delete operations. 2. Does HashSet allow duplicates? No. HashSet stores each unique value only once. 3. What is the time complexity of HashSet contains? Average. O1. Worst case. ON4. What is the difference between HashSet and HashMap? HashSet stores only values. HashMap stores key value pairs. 5. When should you use HashSet? Use HashSet when you need. Check uniqueness. Check fast existence check. Check duplicate detection. Check visited tracking. 6. Does HashSet maintain insertion order? No. Use LinkedHashSet if insertion order matters. 7. How do you get sorted unique values? Use TreeSet. 8. Why is HashSet useful for contains duplicate? Because it can quickly check if a number was already seen. 9. What is the space complexity of HashSet? ON. Because it may store up to n unique values. 10. Can HashSet store null? Java HashSet can store one null value. But avoid unnecessary nulls because they can make logic confusing. 11. What does HashSet use internally? Conceptually, HashSet is backed by hashing. In Java, HashSet is backed by a HashMap. 12. What do custom objects need for HashSet? Custom objects should correctly implement equals hashcode, HashSet roadmap beginner level. Learn. Create HashSet. Add contains. Remove size iteration. Practice. Unique numbers, unique names contains duplicate, remove duplicate values. Intermediate level. Learn. Intersection, union, difference. LinkedHashSet, TreeSet, string duplicate detection. Practice. Intersection of arrays. Unique characters, longest substring without repeating characters. Valid Sudoku basics. Advanced level. Learn. Visited tracking in graphs. Custom object equality. HashSet in sliding window. HashSet in BFS DFS. HashSet in backend deduplication. Practice. Number of islands, graph traversal, contains duplicate 2, longest consecutive sequence, repeated DNA sequences, 30-day learning plan, week 1, HashSet basics. Learn. Control, add, contains, remove, size, iteration, uniqueness. Practice. Create unique number set. Create unique string set. Check if value exists. Remove value from set. Week 2, duplicate problems. Learn. Check. Duplicate detection. Check before add. Arrays with HashSet. strings with HashSet. Practice. Contains duplicate unique characters, remove duplicates, intersection of arrays, week 3, set operations. Learn. Union, intersection, difference. LinkedHashSet, TreeSet. Practice. Union of two arrays, difference of two arrays, sorted unique values, keep insertion order, week 4, interview patterns. Learn. Sliding window plus HashSet, graph visited set, BFS DFS tracking, backend deduplication. Practice. Longest substring without repeating characters, contains duplicate 2, longest consecutive sequence, graph BFS, graph DFS, real-world backend examples. Example 1, avoid duplicate processing, public void process events, list event events. Set string processed event IDs equals new HashSet dot. For event events. If processed event IDs contains event.getID, continue. Process event. Processed event IDs dot add event get ID. Avoid processing same event twice in a batch. Example 2. Validate allowed roles. Private static final set of string. Allowed roles equals set of admin, user, manager. Public boolean is allowed role, string role. Return allowed roles contains role. Use case. Fast validation of allowed values. Example 3. Find missing IDs, public list long, find missing IDs, list long expected IDs, list long actual IDs. Set long actual set equals new HashSet actual IDs. List of long missing equals new array list of long. For long ID expected IDs. If not actual set dot contains ID, missing dot add ID. Return missing. Use case. Compare expected records with actual records. Example 4. Deduplicate API input. Public list, unique product IDs, list.long.product IDs. Set long unique equals new linked hash set of product IDs. Return new array list, unique. Why linked hash set? It removes duplicates and keeps input order. Must know hash set problems. 1. Contains duplicate. 2. Contains duplicate 2. 3. Intersection of two arrays. 4. Longest substring without repeating characters. Longest consecutive sequence 6. Happy number 7. Valid Sudoku 8. Find the difference 9. Unique email addresses 10. Repeated DNA sequences 11. Number of distinct islands 12. Graph valid tree. Number of connected components 14. Remove duplicates 15. Missing number. Final summary. HashSet is one of the most useful beginner data structures. Important concepts. Check unique values, add, contains, remove, size, duplicate detection, set operations, visited tracking, HashSet versus HashMap, LinkedHashSet, TreeSet. Key idea. Use HashSet when you only need to know if a value exists. Use HashSet for seen numbers, visited nodes, unique IDs, allowed values, duplicate detection, sliding window, characters. For interviews. If you see duplicate, unique, visited, or already seen, think HashSet.